Good morning, everyone. How is the Vesak? Usually, in Colombo, Vesak is very decorative, like they celebrate Vesak very nicely. Ratnapura, they celebrate Poson. So, if you want big dancehall, you have to get to Poson. You have to get to Ratnapura and Poson. Okay, so he was sleeping over at Roshan Uncle's place. Yeah, no, I mean yesterday. Yeah, you came from there today. Good. Ah, that's why you came early. It's like somebody drove you here. It's like 5 minutes. Yeah. Okay. Let's start. Up to the last week, we did everything really nicely. So the last week we finished officially only the part for Unit 1. So if you want to write Unit 1 questions from Unit 1 theory, so we done everything up to last week. So when you're going through the tude book, you would be able to answer like almost all questions. A little part is missing. This part actually is not beneficial for Unit 1. This part is beneficial for all the other units, especially to Unit 2, 3 and Unit 6 in organic chemistry. Okay, so the next part is the periodic properties. So our next topic is periodic properties. Periodic properties, and there are 8 periodic properties that we have to go through. But before moving on to that, to understand, I usually do that, like whenever we need to understand special points, I would give special points separately, not within our real theory. So to understand real theory, we need 2 other criteria to go on. One is the shielding effect, and other one is the Coulomb law. Coulomb law you guys know already. So Coulomb law talks about these 2 different charge entities. Let's say we have 2 different charge bodies. What are the most like so-called famous 2 different charge bodies? What is? Yeah, those 2. Plus minus, because proton mean what? That's the nucleus. Around that electrons are moving. Okay, so that let's say this is Q1 and this is Q2. These Q1, Q2 are their charges. If the like the force interaction, internuclear interactions between nuclear interaction between nucleus and electrons is greater, when what happens? Charge is supposed to be greater or less. When more charge inside the nucleus, more protons inside the nucleus, attraction is greater. So that this, whatever the Q1 multiply Q2 is directly proportional to their charges. Understood? That is a part of the Coulomb's law. What about the radius? Radius supposed to be less or high? Radius supposed to be less. So that is opposite. So that's inverse relationship. So the force is inversely proportional to radius, but to get a proper connection, they have to multiply this by, the same radius, that means square value. So that we can say interaction between negative, positive, whatever these 2 entities is directly proportional to multiplicity of their charges, and oppositely proportional or inversely proportional to square value of distance. So this is the Coulomb's law. You just need to know, you already know that when the charge is greater, interaction is greater. When radius is smaller, interaction is greater. So that this is the Coulomb's law. Let me explain you Coulomb's law again. Coulomb's law means the force between 2 charged particles, whatever it is, electron, proton or whatsoever. The force between 2 charged particles is, you have to write directly here, directly proportional to the product of the charges. Directly, and inversely proportional to the square of the distance between them. That is the Coulomb's law. Let's read this one and then let's fill this one. Okay, so let's read Coulomb's law. The force between two charged particles is proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay, it is there on your note, but just put a caret here, right there directly. Your page number 77. And then copy this. Finished. Okay. දැන් මට කියන්න family youngest කවුද හරි ඉන්නවද කියලා මෙතන ඉන්නානේ. අම්මේ තාත්තේ වැඩිම ආදරේ කාටද? පුතා කවුද? Only. Only cannot they never get this experience. Okay, who loves the best of the family? What are the? That's a lie. They always like පුතාටිනේ අක්කි විතරද? කයයනේ. කවුද eldest one? අක්කනේ අක්ක බව. ඔන්න මේ බලන්න අපි සජීව ගමු මේකට. ඔන්න සජීගේ මේ ඉන්නවා. අයියකුයි අක්කකුයි දෙන්නම ඉන්නවනේ. ඔන්න මේ ඉන්නවා E1 පොඩි කෙනා E2 ඔන්න තව අයියකුයි අක්කකුයි අයියා ඉන්නවා. සජී ඉන්නවා අයියා ඉන්නවා youngest කට්ටිය. අක්කා ඉන්නවා එළියෙම. So the eldest whoever is here, let's say E3. So mom saw E3 the very first. So E3 is the person who has given this title, parental title, and the very first time they saw E3's face, so they love E3 so badly. They love and they respect whoever given that position to them. But then E3 innadi later E1 and E2 are coming to the family. Then මොකද වෙන්නේ? They don't have any idea what was the connection between this. They don't have any idea between this connection. Once they get there, like යන්න අහකට අම්මී තාත්ති මගේ නේද? So E1, E2 are repelling outermost shell electrons more away from the nucleus. So that let's say if this is lithium has 3 protons here, 3 electrons outside. So that 3 protons is definitely has +3 charge. But this +3 doesn't feel for this E3 because E1 and E2 are pushing E3 away from the nucleus. So whatever the charge feeling on this E3 is less than that. But E3 knows, අක්කි දන්නවා අම්මි තාත්ති වැඩිම ආදරේ මට අර දෙන්න නැටුව ආවේ කියලා ඉන්නවා. This knows the real attraction. But ඒක feel වෙන්නේ නැහැ. Sometimes complaining නේද? නංගි ආවට පස්සේ මල්ලි ආවට පස්සේ අම්මි මට ආදරේ නැහැ කියලා complaint is going on. But in reality +3 is still there. So this is the shielding effect. This is the shielding effect. The decrease in the attraction force. Decrease in the attraction force. Attraction force between what? Mom and Akki. Mom and Akki. But you guys are decreasing that. there were these there were real incidences. Ayya hari akki hari like your age. Nangi or Mali is like 2 years, 3 years, such very younger. Then parents definitely has to attend 100%. They have to feed them, wash them, dress them. Then akki ayya definitely deviating from parents. Those are the real shielders. Sajiki condition I like you do everything yourself, and like it's just only the love part, I guess, playing. Okay, I'm done. And big part එක මිස් වෙනවා ඒ part එක මේ දෙන්න කියා දෙන්න ඕනේ දැන් මෙයාට. Anyway, so that real attraction is decreasing. So that decreasement of the attraction force of outer shell electrons, which is obviously due to what? Youngers or presence of inner electrons, is called shielding effect. Okay, Senu. මේ online app දැන් එන්නේ මොකද අද ඔයගොල්ලන්ට නින්ද ගියාද? Decrease in the attraction force. Page number 80. Decrease in the attraction force of outer shell electrons, which is obviously due to the presence of inner electrons, is called screening or shielding effect. Okay, so that how much they are feeling is called the effectively how much they feel. But that's not the real part. So no, focus here. Really. Focus really well. Okay, so that is not the real love. So the real love is the real nuclear charge. So this is exactly +3. But outermost electrons don't feel the +3 because of the shielding effect. So +3 minus shielding effect is the part that outermost electrons are feeling. That's called the effective nuclear charge. Understood? Alright, it's 8:15. I'll explain these two phenomena again. The very first one is the Coulomb law. Coulomb law says, okay, we have two main charged bodies. Plus is the protons or nucleus, minus is an electron. So Coulomb law says, let's say the charges of these two are Q1 and Q2. When the charges are greater, multiplicity of the charges are proportional to this interaction between these two. And also when the distance is less between these two, again the attraction between these two are greater. That is the Coulomb's law. Coulomb's law says opposite charged particle is proportional, their forces directly proportional to the product of the charge and inversely proportional to the square of the distance. We done that part. Couple of online students also missed that part. And then the shielding effect mean when there are Sachiv, explain this, darling. අනේ ප්ලේස් එකක් තියෙනවා. මෙන්න ඉන්නවා අයියක්කි. මෙන්න ඉන්නවා ඔය. Okay, how do you explain the shielding effect? Oh sorry, අර ඉන්නේ අක්කි. ඔයා පළවෙනි එක්කෙනා. youngest මේ youngest කට්ටිය. මේ තියෙන eldest එක්කෙනා. Me and my brother come to the family, then Aki is getting deviated because parents are like supposed to give more attention to us, and then I and my brother are saying, just you get away. Mom belongs to us, dad belongs to us, so just stay out of them, stay out of parents. So that what happened? So she is little deviating, getting away from parents. That is called the shielding effect. So in chemistry sense, inner electrons inner electrons are these. They decreases the amount of attraction fields between outer electrons and nucleus. So inner electrons are pushing outer electrons more and more out of the nucleus. So that's called the shielding effect. So that, tell me, Shielding effect, a longer period, increasing or decrease. Sorry, downwards a group. Shielding effect. Shielding effect. Increasing why? හිතන්නකො සිබ්ලින්ස් ගොඩාක් ඉන්නවා ඔය වෙලාවට යනවා නේද නිකන් ස්පෙෂල් නිවස් විදියට යනවා නේද මේ අම්මට බබාලා මේ ලොකු ඉතින් ලොකු කට්ටිය එතකොට මේ අම්මට ළමයි 15ක් ඉඳලා තියෙනවා 20ක් ඉඳලා තියෙනවා කියලා එතකොට I have this experience sometimes these people are saying like then school එකට ගිහිල්ලා like lot of කට්ටිය ඉන්නවා එතකොට මේ ඇතුලේ ඉන්නවා E1 E2 E3 E4 E5 ගොඩක් ඉන්නවා ඉන්නකොට මොකද වෙන්නේ දැන් ඒගොල්ලන් ගිහිල්ලා දැන් ක්ලාස් එකකට අර පේරන්ට්ස් මීටින් වලට එන්න කියනවානේ මේ පුතාගේ නම මොකක්ද කියලා අහුවම දැන් තාත්තට නම මතක් කරගන්න බෑ ළමයි ගොඩයි ඉන්න ෆැමිලි එකේ likewise when inner electrons are greater and greater and greater what happens outer electrons are pushing more and more away from the nucleus so that the nucleus that the radius of the atom is increasing. What is the main reason that the radius of the atom increases? Going down the group. This is not the main reason. Yeah, අර හෙසඳුට වෙච්ච දේ කියන්න තියෙන නේද? දැන් හෙසඳුට automatically he gets full attention. So that happened to what? That's a special part. Hesandus, okay, if you are the only child of the family, if you are the only child of the family, then who do you have? නේ එහෙනම් මෙයාට definitely shielding party යනවා. But that's cute. Do you love them? Then නැත්තත් හදලා දින්නේ. How old are they?
Look, I have kids.
Yeah. You have your own twin sister. That's like then. What is that condition? 2 electrons in one single shell. What is the element?
Helium.
That's helium. What is your element? Wow, you guys are really, really really talented. Okay, for hydrogen, does this shielding effect acting? No. For helium, almost no. Maybe parents are sometimes favoring daughter, sometimes favoring son. A little difference is there. Why is that? Still you cannot expect even such difference you cannot expect here because you have one nucleus, let's say one nucleus and then what is this shell? 1s, how many electrons? 1s2, where are they? Exactly same. Understood? Even there for lithium, beryllium, so on, this attraction is less because when the size is smaller, these electrons are so much away from each other. So, okay, 2 electrons in inner shell, 1 electron in outer shell, so that the shielding effect is less. But when you are going down and down and down, what happened? So, my inner shells mar vidiyata pirenawa and lots of electrons are here. All those electrons are pushing other electrons away from nucleus. So, the outermost electrons are going so much away from that. So, shielding effect is increasing. Other than that, now I know you guys never forget these 3 conditions. Hydrogen, no shielding effect. Helium is the shielding effect. Helium has no shielding effect, even it has 2 electrons. Other than that, it's increasing when the number of orbitals, energy levels increasing. The main reason that your radius is increasing going down the group, electrons are always entering into new energy levels. Okay, what is this energy level or this period or this principal quantum number? 1. This one? 2, 3, 4, 5 and 6. Okay, so what happened? What is the meaning of the difference between the main difference between 3 and 4? 3 has 3 main energy levels. 4 has 4 main energy levels. Understood? So 1 extra energy level is there. Always electrons are filling to new outer shell energy level so that the size is increasing. Okay, get this knowledge. And remember, using this knowledge, last year 2020, 5 okay, අයියා කෙනෙක්ට පුළුවන්ානේ island 6 වෙන්න මේ knowledge එකෙන්. එතකොට ඔයාලට තව 5යි පහු කරන්න තියෙන්නේ. හැබැයි එයාගේ මම කියන්නේ එයා වෙන ක්ලාස් එකක තියෙන නිසා මොනවයි කියලා. You guys know my මගේ notes හදද්දි මම මේක මෙතන මාරට කියන්න මගේ notes හදද්දි I started my advanced this journey in 2019. So the very first when I started I wasn't happy with. I don't say that there weren't perfect teachers for chemistry, but maybe I couldn't find good notes. Anyway, I couldn't find good notes. Whatever the notes I found, I wasn't happy with them. So the story is not clear. It's not matching. Some points are missing. Like I was feeling like medical student connect to the a middle part is missing. How do they understand that? Then I collected like 20 units, 20 notes. You know how much tiring process is that. So then I was comparing all those 20 units. Then I made this best note and still I had issue. Still I wasn't happy. Like even when you made this beautiful note, what is the final target? Answering the final exam paper, having the exact same style of all the years. If you start from 1979, I started from 1979. 1979 and 1980 has very little difference. 80 to 81 has very little difference. So on, let's say you are doing your exam in 2028. So 2027 and your paper has very little difference. But that style wasn't there on the papers. Then what I did was, I did all those papers up to at that time, 2079 to 2019. How tiring the process. I had like 2 hours, 3 hours sleep every day. And at the morning time, I had to do classes as well. So that I gathered all those marking schemes and then I changed my points according to the marking scheme. So far, whatever we done have less relevance to the final exam. Like very, very little parts contribution to the final exam. But from here on, whatever you are writing, when they are asking structured essay questions, you have to write exactly the points I have explained. Understood? So remember that when you are memorizing these, not like bio. Bio is like you have to memorize each and every single point. You don't do that like you are not writing like that. But when you are memorizing things to write for structured essay, just think this is the way I have to memorize. If you are not doing biology, this is the way somebody has to memorize biology. Likewise, each and every single point with all the keywords you guys have to memorize. And when you are writing, anybody who's doing biology here? Yeah. Then the secret of reaching 100 marks for biology is, okay, let's say that you have 10 points to write. You have 10 points to write. Let's say you have, let's say, make 7 points, 7 points to write. They are asking only something with potassium. Potassium and sodium. They are only asking about sodium and potassium, but still you are writing all 7 points. So they are asking only about, let's say, only if they are asking about sodium, still you're going to write all 7 points. Let's say they are asking about all 7 elements, then still you are writing all 7 elements. I want you guys to use that little trick for chemistry when they ask you to explain something. So that is the part each and every year that my students cannot reach 100. Maybe they are reaching 99.5, 99.6, that's possible. Reaching 100 is difficult. You guys are reaching, if you do this job really, really well, there were in my past in 2000, maybe I got the 48 MCQs, but yeah, highway unata. මගේ 29 වෙනි වුණා කලින් අවුරුද්දක girl කෙනෙක් එයා 50 out of 50 ගත්තා chemistry වලට. So that's possible. It's not impossible. But 100 යන්න බැරි වෙන්නේ second paper එකේ අර චූටි points miss වෙන නිසා. So that make sure when they are asking something little you are writing better than that. You have to explain it beyond their expectation. And you guys know there are this bonus marks. There are bonus marks that they are asking only about something little with potassium. But then, let's say potassium and rubidium. But then when you are taking the big view, there are like much deeper, much understandable points are there that they were not expecting, but you are writing beyond their expectation. Let's say one structured essay question, you get 100 marks. Anyhow, let's say for some reason you lost 2 marks. So your total marks is 98. 98, but then you were writing something to another little part of this one, so which is awarding 4 bonus marks. Understood? So this never become 102. because then your final marks will become above 100. So, but maximum to limit to this 100, they are giving this 4. Then 98 to 4, 102, but they are giving 100. Let's say your marks is exactly 96, then that's become 100. Let's say your marks is 90, so this is become 94. Bonus marks is there. When students are writing impressively, each of these exam centers have a head. That head is reporting to the big head, the boss of everything. He is usually in Colombo. This day is really busy. Everybody is asking different questions and like aim communication එකක් කියන්නේ. So that it is happening. It is there. So make sure if you want to reach this highest successness, මගේ students කොහොමත් reach වෙනවා. Don't trust your own results. Only trust this advanced level path and these 3 subjects. Today Sajiv had little issues. He came a little early today. Same thing I'm telling you guys. Whenever you feel like something is missing, එකම එක වීක් එකයි ඔයගොල්ලෝ හක දාන්න. ඒ වීක් එක ASCII මහ ලොකු අවුලක් මහ ලොකු පාඩුවක් වුණා කියලා හිතාගෙන ඒ වීක් එක ASCII එක sort out කරගන්න ඕනේ. Let's say you had some issues with combined maths that you don't feel like they are doing enough questions, or let's say that when you are trying to do these exam questions, you don't feel like there is this connection that you are doing theory somewhere else, but when you are coming to exam questions, that is the way you can measure yourself. You can measure whatever the sirs or teachers are doing good. Just try to do exam questions from that part. If you can answer that, then you are going with the path very smoothly. Otherwise, you guys need a separate support. Remember that, okay? So that remember such points like very like exactly the way I'm explaining. So that let's move on to this shielding effect because we did this Coulomb's law. Okay, let's read. Let's read. Okay, you guys can go through the board screen. Let's read. Shielding effect. Properties of atoms depend on their electron configuration and attraction of outermost electrons to the nucleus. Who talked about that? Attraction of outermost electrons to the nucleus is what? This is part of Coulomb's law. Then attraction increases how? When charge is high, when distance is less. Okay. According to Coulomb's law, the attractive force between an electron and the nucleus increases when the magnitude of the nuclear charge increases and when the distance between nucleus and electrons decreases. But outer electrons experience attraction from the nucleus and also repulsion from inner electrons. The decrease in the attraction force of outer shell electrons, which is obviously due to the presence of inner electrons, is called shielding or screening effect. For valence electrons, most of shielding is due to the core electrons. What is the meaning of core electrons? Inner electrons, which are much closer to the nucleus. Therefore, when greater the number of core electrons, higher the number of core shells, the greater will be the shielding effect. Okay, now what happened? Downwards a group. Downwards a group, since electrons enter to new energy levels, it increases number of inner shells and hence number of core electrons. Therefore, downwards a group, shielding effect increases. From left to right, across a period, number of core electrons stays the same. This causes shielding effect remains almost unchanged, but effective nuclear charge increases. We didn't discuss that, but I'll explain. Shielding, steadily across the period since number of protons increases. Okay, what happened there? Okay, along a period, what happened? What is the condition for along a period? See, obviously, radius is being decreased. What is the reason for that? Yeah, see. Okay, then මෙතන මොකද වෙන්නේ? 1 2 3 4. This is the fourth energy level. Okay, what is the last shell electron configuration of potassium? We did. No, advanced level now. No, the last shell. This is in the fourth energy level. And this has one single electron. So, yeah. So this is become 4s1 and calcium 4s2 and boron, sorry, gallium well done. Then germanium 4p3 4p4 4p5. So regardless how many electrons are entering, all electrons are entering to one single main shell. Inner electrons මොකද වෙන්නේ? එකපාරට it's like අර බබාලා අස්සේ ඉන්නද්දි එළියට අක්කිය අයියලා හම්බුනා හිතන්නකෝ හම්බුනායි කියලා බබාලා හතරක් එක සැරේ මොකද වෙන්නේ? එතකොට there is no such new shielding effect. තේරුණාද? ඒතර අස්සේ දෙන්නට වැඩි එළිය හතර දෙනා ලොකු වෙනවා. ඒ වගේ හතර දෙනෙක් අක්කලා ඉන්නවා twins ලා වගේ හම්බුනා කියලා හිතන්න. So big 4 is there. So what happened then is electrons are entering to same energy level. Same energy level. Electrons are entering to same energy level. So it doesn't increase the inner electrons. So that shielding effect is ineffective here. There is no shielding effect acting. Understood? Okay, so no point of talking about the shielding effect. But then, what happened to this? So the electrons are entering to one shell, so that the connection between electrons and nucleus become what? It's increasingly high now. Because more Q1, Q2 is greater, more attraction. So number of electrons are greater. Understood? What happened to the inner protons? Are also increasing. So that the Q1 increasing, Q2 increasing, Q1, Q2 increasing, more attraction. When the nucleus electron attraction is greater, let's say nucleus, this is electron, what happened? So they are attracting more and more towards nucleus. What happened to the size? Decreases. Size is decreases. So along the period, radius is decreases. Okay, let me go back to that part. This is the part that we were talking here. Let's read this together again. From left to right, across the period, number of co-electrons stays the same. This causes shielding effect remains almost unchanged, but effective nuclear charge increases steadily across the period since number of protons increases. Those are the explanations for why along a period radius is increasing. So that this is a real effective charge. This is a real your mom's love. But you don't feel it enough with the shielders. Shielders are what? Inner electrons. So you feel only the difference between these two, which is called the effective nuclear charge. Effective nuclear charge is always less comparing to real. True love is always greater. Only thing is mom or dad has to attend with younger siblings so that you don't feel like the real attention. Then it feels like the less attraction, but the real nuclear charge is always greater than effective nuclear charge. Understood? Let's read. Due to above reasons, there is a certain pattern in properties of elements. Properties which are periodic functions of their atomic number are known as periodic properties. Alright, so if you have the memory, go with the memory. Otherwise, look at the screen. Let's copy this. It's a little big part, okay? These parts are very important than the normal theory of unit 1. Hang on. Ah, yeah, correct. Sinhala එකේ තිබුණ පොඩි වෙනස. දැන් අපි එක්සෑම් එකක් කරමුද? බයිද? නම් මේ එක්සෑම් එක ඩිෆරන්ට් එකක්. එක්සෑම් එකට ඔයගොල්ලෝ ආසයි. This is a beautiful weather. මේකේ පොඩි පාර්ට් එකක් යනවා. Have you ever heard about open book exams? නෑ නේද? අහලා තියෙනවද? කළා තියෙනවද ඔයගොල්ලෝ? නෑනේ. ඒවා තියෙන යුනිවර්සිටි ලෙවල් එකට. මම ඒවා ඔයාලට ඇප්ලයි කරනවා but it's really successful. open book exam අපි කියලා බලමු. ඉවරද ඔයගොල්ලෝ ලියාගෙන? මේ පාර්ට් එක චෙක් කරගත්තා. I'm going to read this again, but I want you guys to do it for first. Make it up to 2 hours only. Okay, so I'm going to give you guys this break a little bit of time. Okay, copy the equation. Copy the equation. I'll show again. I'll read again. Let's fill the missing part. We have 2 options. Before we moving on to unit 2, I want you guys to complete as much as possible this unit 1 tude book questions, because those are, it's a must before the exam. It's a must that you complete Tude 1. But we have 4 hours here. And your final exam is an exam. And your term test is an exam. Then timing, time management, stress management and everything is there. Whether you need to make like how much memory you have is not there. Then every day, not every day, like let's say every other day also we have to do exams as well. But when you are doing exams, theory is okay, I can manage, but time that I'm using to do these tudes are getting down. So we have 2 options. Either I can give you to do this paper at home. At the class we are discussing tude book. Otherwise, I have the tude book full these recordings completely, very nice recordings, exactly the way I have done for other students. I have these recordings with me. I can post those recordings to the group so that you can listen those recordings and you can fill your note. I'm the tude. Discuss and let me know. Anyway, within the halfway of unit 2, you guys, it's a must that you guys complete unit 1. So I've seen this one in my history what happened. Unless otherwise you do it right at that time, when your workload is increasing, you would feel like unit 1 is less important, unit 1 doesn't give much contribution to the final exam, we don't want unit 1 enough, then you don't feel like doing that. But it is a must that you cover everything. You don't know which question they would ask for your exam. They always try to find questions which is harder for students and which are not frequently asking. So it is always there. So you have to make sure that you are not giving any excuse for them to get rid of your marks. Understood? Okay, today during the break time, let's discuss and let me know which method you guys need to do. I prefer that you guys are time to time doing it. It's not always questions are doing with the recordings. Time to time. Let's say that today, first I thought I want to do questions here, but then I thought I want to do this paper here. Because this paper is a must, because this paper is little, very sort of a challenging. You can do this paper all by yourself. Like sometimes, very rarely some students do. Otherwise, this paper is really challenging, structured essay and essay. But once you guys discuss together with each other, brainstorming, then you can get answers. And let's see how you guys would go. Okay, anyway, let me read this one. Let me know during the break, discussing with each other. Okay, you can look at your note and let's read again. Shielding effect. Properties of atoms depend on their electron configuration and attraction of outermost electrons to the nucleus. According to Coulomb's law, the attraction force between an electron and the nucleus increases when the magnitude of the nuclear charge increases and when the distance between nucleus and electrons decreases. But outer electrons experience attraction from the nucleus and also repulsion from inner electrons. The decrease in the attraction force of outer shell electrons, which is obviously due to the presence of inner electrons, is called shielding or screening effect. For valence electrons, most of shielding is due to the core electrons, which are much closer to the nucleus. Therefore, when greater the number of core electrons and higher the number of core shells, the greater it will be the shielding effect. Downwards a group, since electrons enter to new energy levels, it increases number of inner shells and hence number of core electrons. Therefore, downwards the group, shielding effect increases. From left to right across a period, number of core electrons stays the same. This causes shielding effect remains almost unchanged, but effective nuclear charge increases steadily across a period since number of protons increases. Effective nuclear charge equals nuclear charge minus shielding effect. Therefore, effective nuclear charge is always less than real nuclear charge. Due to above reasons, there is a certain pattern and properties of elements, properties which are periodic functions of their atomic number are known as periodic properties. The meaning of function means it is changing when you are going along a period, if any property is changing, it's a function of that period. So those are called periodic properties. Alright, so the very first one is so there are 8 periodic properties. These are really important. You guys have to memorize these 8 periodic properties so well for the final exam, not to answer the questions of unit 1, as I told you guys. Okay, so as an example for unit 2, there is this little subtopic electronegativity, and electronegativity variation is given. It's a must that you have to memorize exactly this increasing order of electronegativities when you are going to unit 2 to do this Lewis structures. Lewis, you done for all of them. Yeah. That Lewis and this Lewis are little different. Same Lewis, but advanced like electron configurations. Okay, so the very first topic is the size of atoms and ions. Okay, let's say if this is just atoms, if these are just atoms, so the variation goes the normal the way. Let's say if these are ions, okay, what are the ions of, let's forget this one. Hydrogen doesn't come to the group 1, okay. What is the ion of lithium? Lithium can possess only one single ion. What is that? Just think and tell me. What is the electron configuration of lithium? 1s2, 2s1. Okay, I'm going with sodium. Then 1s2, 2s2, 2p6, 3s1. Okay, now tell me. What is the ion they can make? Just a +1. Why is that? Once you remove this electron, you can't reach the inert configuration. That is the reason. Understood? So that always they are making lithium plus, sodium plus, potassium plus, rubidium plus, cesium plus. Plus charge is common to everything, all the ions. So the trend going down the group, does it changing? No, not changing. Either atom or ion, their properties are exactly same for all the groups. Understood? So what is the main ion of group 13? Okay, if I go with අපි යමුකෝ gallium යන්න පුළුවන් අපිට. Gallium අහුවෙන්නේ කියන මේකත් හිතලා පුරුදු වෙන්න. In between these two, what are those there? This is calcium and this is calcium, same group. This is fourth period. After calcium, what is the next element? No. Strontium is not downwards. I'm asking the next same period. Go through you guys have turned the periodic table. Now tell me, what is the next element? Scandium. You said scandium. Oh, I thought it's strontium. Yeah, so the next element is scandium. So next element is scandium. Okay, D block elements are ending of what?
Zinc.
Zinc. And then what's the next element? Gallium. So next element is gallium. Understood. What is the last shell electron configuration of gallium? Okay, focus well and tell me. Group 13. 4. Yeah. 4s. Mama මෙහෙම තියන්න. 4 එකක් මකන්න ඕනේ. අන්න මම දෙනවා 4s2 4p1. Okay, that is the last shell configuration. So after 4s2, what is there in of bow? Do you guys know? Yeah, 3d. Now zinc is filling. Let's say if this is zinc, don't forget that you have 4p1. Okay, so zinc, what's zinc configuration? 4s2, 3d. 3. No. Make it again. Then after 4s2 ඉවරයිනේ calcium. With the 3d 1 2 3 4 කියලා 10th element එකට එනකොට කීයද වෙන්නේ 3d? Yeah. 20th element is OS2. Then plus 10 mean 3d 10. So this is okay, see. මේ බලන්න හිතලා ගන්න පුළුවන් ඔයගලන්ට. මේක 3d 10. Understood? Yeah. Okay, how many electrons are you losing now? So the last electron enters to P, so that you fall this to P block. Alright, now tell me, what is the inert configuration? How many electrons are you losing to get the inert configuration? You are losing 4p1 and 4s2. Understood? 3D10, up to 3D10 everything is there. Understood? What is that inner configuration? 1 up. මොකද ඒ configuration එක? 3ක් නේ අයින් වෙන්නේ. ඒතර කාර්යය යන්නේ. God. Understood? So that, now tell me, what is the normal cation for group 3? Group 13? Plus 3. Yeah, that's 3 plus or plus 3. So plus 3, plus 3, plus 3, plus 3. So group 15 maximum, plus 5, plus 5. So all are having plus 3, all are having plus 5. So going down the group, atomic trend is exactly same as ionic trend. Understood? Okay, so that still electrons are entering to new energy levels, and also shielding effect is increasing, so radius increasing. Along a period, shielding effect is ineffective, but protons are increasing, so more nuclear attraction. So the electron cloud is squeezing, so that the size is decreasing, radius is less. Clear that? Alright. Let's go through that first little part here. This is a little longer topic, other topics are shorter. Okay, let's read. ඔයාලගේ ළඟ තියෙන දේවල් දැන් හිතන්න 10 years you guys are learning theory, but unless otherwise you get this practice to answer questions, you can do that. So I'm always trying to awaken some part of your inner thinking, your inner thoughts. It is there. දැන් ඔයාලා advanced එක කරන්න eligible නේ, age එකත් eligible. Results එනවා මේ week එකේ. Next week, you're going to turn into new leaves. Then you're going to have more determination. I definitely have to do this. 9S avot confidence තියාගන්න that 9S is exactly same as less than, not same, less than the weight of one single advanced level subject. මම ඒ වගේ 3 times greater work එකක් ඕනේ advanced level වලට. If you get less than that, just think I would never let this happen to advanced level. Do you believe මේ true stories? මේක මම අනිත් ටියුෂන් කට්ටියට කියනවා සමහරක් අයට ඉවරන්ට ඇති එක්ස්පීරියන්ස් එක ඇති. O level results 3A's එකක් නැති ළමයි. O level 9A's වල 3A's එකක් නැති ළමයි. Advanced level 3A's අරගෙන medicine engineering යනවා කියවම, do you guys believe that? Inner energy, your inner energy. So I'm always trying to wake that energy. That's why I'm asking you such questions. Then predictable එකේ කොහේ කොතන කවුරු හිටියා වුණත්, thinking of the relevant non-electron configurations, you can very easily get electron configurations of other species. මම දැන් එතෙන්ට ගිය නිසා තව චූටි එකක් මම මෙතන ඔයගොල්ලන්ගේ ඔළුවට දාන්න just කියනවා විතරයි. දැන් අපිට එකපාරට ඕනි වෙනවා to get the electron configuration of this let's say all of a sudden that's the tin කියලා. අපිට inner shell configuration එකක් ඕනේ, because the outer shell we know if this is 5, this is 5s2, 5p2, we know that. Understood? But before that, what do you have? You have cadmium above zinc. So what's the zinc configuration? You know that. Understood? So එතකොට මේකේ හදා ගන්න පුළුවන් නේද මෙතන කවුද ඉන්නේ කියලා. දැන් මෙතන ඉන්නවා cadmium වල අපි ඉන්නවා. zinc වල අපි එනවා 4s2 3d10. එතකොට cadmium වලට අපි එනවා 5s2 4d10. එතන මෙතන 5s2 වලට කලින් ඉන්නේ 4s2 4p6 ඉවරයි. 5s2 4d10 then 5p4. එතකොට යන්නේ එළියට කවුද? මේ යන්නේ මේ දෙන්න. හැබැයි මේ මෙතන inner configuration එක හැදලා ඉවරයි. ඒ කියන්නේ කාටද? cadmium වලට උඩ ඉන්න එක්කෙනා, ඒ කියන්නේ krypton වලට. ගියාද ඔළුවට? So මේ දේවල් ඔයාලට වෙන කියන්නේ පොතකින් ගන්න බෑනේ. Make a practical part. When you feel like that you missed something, go to that recording and listen that recording to get those. Like අර එහෙම වුණාම තමයි අර සමහරක් ඔක මේ ස්කූල් යාළුවෙක් එක්ක ඉඳලා වැඩ කරද්දි වෙනවා. ඒ කියන්නේ සමහරක් අයට unbelievable කොහොමද එහෙම වෙන්නේ කියලා. So එහෙම වෙන්න හැමතිස්සෙම there are reasons. Magic නෙවෙයි. Reasons ටික if you get to your brain, the chemistry life is really easy. And apply these for other two subjects. හැම එකේම චූටි secrets ටිකක් විතරයි තියෙන්නේ. Subjects become very easier. Okay, let's read. Downwards a group, number of energy levels increases. It tends to increase in the number of electrons in the inner energy level. Therefore, shielding effect also increases. Therefore, radius increases downwards a group. Next point. Across a period, nuclear charge increases. Therefore, attraction towards outermost energy level is also increases, causing the outer energy level to contract. In turn, decreases the radius. Since core electrons remain constant, shielding effect is ineffective. Therefore, across a period, radius decreases. Clear? Feel that part? Down as a group, number of energy levels increases. It tends to increase in the number of electrons in the inner energy level. Therefore, shielding effect also increases. Therefore, radius increases downwards a group. Across the period, nuclear charge increases. Therefore, attraction towards outermost energy level is also increases, causing the outer electron level to contract. In turn, decreases the radius. Since core electrons remain constant, shielding effect is ineffective. Therefore, across a period, radius decreases. Alright. අපිට දැන් පොඩි ප්‍රශ්නයක් එනවා. දැන් අපිට radius එකක් ගන්න නම් there are supposed to be exact solid boundary. Let's say if this is a nucleus, if this is the large shell, whatever this electron orbital, so if this is the case, we can get this distance very easily. So this is the radius. Understood? But what do you know about these orbitals? They have this diffuse electron cloud. So you cannot define the exact position. Heisenberg uncertainty principle. So there is this little issue here. So what happened is then, what they done was, they were taking two different atoms, atoms here. Let's say this is Cl2. If this is Cl2, these two of these atoms are exactly identical. So once they make the bond, they get the difference between these nuclei, and if they divide that by 2, that internuclear distance is the radius. If it is with covalent bond, covalent radius, metallic bond, metallic radius, ionic bond, ionic radius, and so on. Understood? Have you ever thought what is the meaning of this covalent bond? Covalent bond is what? Electrons are sharing. Okay, what are they sharing? Can they share electrons? Can they share valence electrons? Just think the physically real possibility. Where's this electron? It's in this orbital, and the electron is continuously, without any particular direction, it's moving. Understood? So how do they make sure they are sharing electrons? They don't share electrons. They are sharing what? They are sharing orbitals, mixing orbitals, overlapping orbitals. So this mixing part, this part is the shared part. This is the shared part. Understood? This is the shared part. So most of the time, since two plus charges are here and these minus charges, since two plus charges are here, minus charges are more trapped into that. Most of the time electron can stay here, but not all the time. Anyway, they are moving around and around and around. Understood? So that the overlapping part is here. This overlapping part is there, but forget it is there. Just consider මේ atoms දෙක තියෙන මෙහෙමයි කියලා. මෙහෙමයි කියලා. Then one nucleus, the other nucleus, get the distance divided by 2 is exactly the radius. Understood? So අපිට මේක කරන්න පුළුවන් ද anions and cations වලට. What do you know about the radius of anions and cations? දෙන්න ඒකට උත්තර. Which radius is smaller? Let's say we have same oxygen, O plus, O minus. O plus is what? Cation is what? Less radius. Why? Very good. You guys are, your brains are working really good. Why? Because now because now less electrons. When the electron number is less, the nuclear proton is still the same. So they try to drag more and more these remaining electrons. අර ඒකද මම අර අම්මා බබා මැරුණු කතාව කරන්න කියලා දුන්නේ. බබා මැරුණාට පස්සේ මොකද වෙන්නේ? බබාලා හිතන්නකෝ අම්මෙක්ට ඉන්නවා 2 kids. අම්මෙක්ට ඉන්නවා බබාලා දෙන්නෙක්. මෙම බබාලා දෙන්නෙක් ඉන්නවා එක මාම්ට බබාලා දෙන්නෙක් ඉන්නවා. එක බබෙක් මැරෙනවා. ඒක අනිත් බබාලා මොකද කරන්නේ අම්මා? මාර attract හැමතිස්සෙම බයින් ඉන්නේ. අනිත් බබාලා මොනවා හරි වෙයිද කියලා. අහකටවත් යන්න දෙන්නේ නැහැ නේද? ඔය ගම්වල වෙලාවකට චූටි වතුර බේසමට වැටිලා අහලා තියෙනවද දන්නේ නැහැ ඔයගොල්ලෝ. ඒ කියන්නේ චූටි වෝටර් බේසින් එකට වැල්ලත් බබා මැරිච්ච කන්ඩිෂන්ස් තිබිලා තියෙනවා. චූටි ළමයින්ට තේරෙන්නේ නැහැ නේ සෙල්ලම් කරනවානේ ඔක අස්සර වැටෙනවා. ඒතොර එයාට හිතන්නකෝ චූටි බබෙක් කියලා වෙදි ගන්නත් බෑ කියලා. එයා මැරෙනවා. ඒ වගේ කන්ඩිෂන්ස් නැත්තම් චූටි ලිංග වලට ගිහිල්ලා මැරෙනවා. එහෙම වුණාට පස්සේ මොකද වෙන්නේ? අර ළඟ ඉන්න අනිත් ළමයි ගැන අම්මගේ attraction එක ගොඩාක් වැඩි. Likewise, once you remove one electron, attraction towards the rest of electrons are really high. That's why if you go with one single condition, cation is always smaller because electron cloud is more and more squeezing towards nucleus. Understood? Okay, so that අපි හිතමු එහෙම condition එකක් කියලා. So now you have one anion and one cation, one anion and one cation. Can you get this distance the same way? No, you can't. If you divide this by 2, anion and cation supposed to have here have same size, but in reality anion and cation sizes are different, not same, because these two are not identical. Let's say you are going with sodium chloride, sodium plus Cl minus, their sizes never become identical, two different. At that time, arbitrarily, just they consider, because we don't have anything else to do, are a diffuse electron cloud, they consider it as there is no diffuse electron cloud, it is rigid, and you can measure the exact boundary. In there, they go to sort of a mean value. Clear that? For anions and cations, they don't have any other option. Understood? Okay. So that we're going to define these 4 radii. We're going to define these 4 radii. What is covalent radius? Sharing. What is metallic radius? The radius, the distance between nucleus of 2 atoms of metal. Understood? What is ionic? The radius of any ion. So this is a new part. Van der Waals. Repeat, Van der Waals. Have you done this for all of us? No. Van der Waals. Kenna? Van der Waals. Van der Waals. Van der Waals. Van der Waals become very comfortable to you guys and frequently using it's become very familiar when you are doing Unit 2. ඊට කලින් අපි මේ කවුද අපේ සජීව ඉන්නේ මම හිතන්නේ ලස්සන ගමක කියලා නේද? ලස්සන ගමකද ඉන්නේ? කුරුණෑගල මහ ගෙදර අම්මලාගේ තාත්තිගේ ළමයිද? තාත්තිගේ වල තාත්තිගේ මහ ගෙවල් කුරුණෑගල. මට මෙමරි තියෙනවද අහල පහල දුවනවා පයින්නවද ගෑස් වලට වෙලා ඉන්නවද? දුවනවනේ. එතන මට කියන්න මෙන්න සජීවගේ ගෙදර සජීව ඉන්නවා. අපි අක්කයි අයියා එනෝමු. සජීව ඉන්නවා අම්ම ඉන්නවා තාත්තා ඉන්නවා. හරිද? ඊට පස්සේ මට කියන්න කවුද නේබර් ඉන්නේ කියලා. අල්ලයාම ළඟම ඉන්න ගෙදර කවුද ඉන්නේ කියන්නේ? ඊට කිට්ටුවම. කවුද? ආන්ටි කෙනෙක් ඉන්නවා. ඔන්න ඒ ආන්ටි ඉන්නවා. වෙන කවුද ඉන්නේ ගෙදර? එයාගේ අංකල් ඉන්නවා. මල්ලියෙක් ඉන්නවා. ඔන්න හරි. තව නේබරි ගෙදරක් තියෙනවා අනිත් පැත්තේ. ගම්නේ. ගම්සල ලේන්ස් නෙවෙයිනේ තියෙන්නේ. කියන්නේ. ඒ ගෙදර කවුද ඉන්නේ? කාව හරි දාන්න? ඒක very good. very good. මට 100 කෙනෙක් තමයි ඕනේ උනේ. 100 ඉන්නවා. ආච්චි ඉන්නවා. මාමි කෙනෙක් ඉන්නවා කියන්නේ. කවුද ඉන්නේ? ඈ? මාමද නැද්ද කවුද? මාමික් ඉන්නවා. ඔන්න මාමි කෙනෙකුත් ඉන්නවා. මම මේක ළඟ ජොයින් කරන්නම්. ඔන්න මම එහෙම ජොයින් කරොත් මම මේ හදන්නේ මොකක් වගේ කියලාද ඔයගලන්ට පේන්නේ. මේ සජියගේ ෆැමිලි එක ගන්නකො. මම මේ හැදුවේ water molecule එකක්. මෙන්න ඉන්නවා ඔක්සිජන්, මෙන්න ඉන්නවා හයිඩ්‍රජන් හයිඩ්‍රජන්. මෙන්න ඔක්සිජන්, හයිඩ්‍රජන් හයිඩ්‍රජන්. ඔක්සිජන් sorry. එයාගේ වැරදුනයි ඔක්සිජන් එකේ තැන. ඔක්සිජන් මැද වෙන්න ඕනේ නේ. ඔක්සිජන් ඉන්නවා, හයිඩ්‍රජන් හයිඩ්‍රජන් ඉන්නවා. So these three different water molecules. දැන් මොකද වෙන්නේ බබා equal? ඉන්නවා. දැන් මේගොල්ලන් ඉන්නේ හිතන්නකෝ ඔයගොල්ලන් අද ගෙනාව water bottle එකක් ගෙනාවද කවුරු හරි අද? මේක water bottle එකක් කියලා හිතන්නකෝ. දැන් මේ ඔන්න families තුනක් ඉන්නවා. වැඩිම යාළු කායකද සජීව? වැඩිම යාළු කායකද? මාලියත් එක තමයි වැඩිම යාළු. එතන මේ attraction එක ටිකක් stronger. වෙනට 100ක් පවනේ නේද? 100 දැක්කොත් 100 කොහමද? පුතේ කවද්ද ආවේ? ඔයා හොඳට ඉගෙන ගන්නවද? කතා කරනවා නේද? මම connections තියෙනවා. So අර මල්ලිගේ ආන්ටි අංකලුයි මේ 100ත් එක්ක hello hi කියලා අංකල් කියලා ඔය connection එකක් තියෙනවා. ඔන්න කාලයක් ගියාට පස්සේ 100 මැරෙනවා. This week in October class then මම ඔය ටික කියලා මම කිව්වම 100 මැරෙනවා කියලා. There was this boy, like whenever you hear sometimes that for instead of Colombo recordings, I'm posting the other class recording when the volume is sounds are poor quality or something. Then Vihanga Kira, that boy was like, "Nah, miss, me see ya කොහොමද මැරුණා." මේ මැරිච්ච සීයක කියලා කියන්නේ. Let's say ඔන්න සීයලා මැරෙනවා. මුළු පවුලම මැරෙනවා. පවුලම මරමු. Oh, they are moving to somewhere else. මොකද වෙන්නේ? එතකොට මෙතෙන්ට තව 3 දෙනෙක් එනවා. මෙතෙන්ට වෙන කට්ටියක් එනවා. වෙන කට්ටියක් එනවා. එතකොට ඔයගොල්ලෝ මොකද කරන්නේ? සිය නැහැ කියලා අඬලා ඉන්නවද? නෑ. Then you are making connection with these new people. නේද? These connections what happen? These connections all the time making and breaking. Making and breaking. These connections are making and breaking. Understanding? Such connections are called van der Waals connections. Van der Waals connections in between families. Okay, දැන් මට කියන්නකෝ water molecule එකක් අස්සේ තියෙන connections මොනවද කියලා? No. What I කිව්වා මොනවද? Covalent bonds. Covalent bond between oxygen and hydrogen. Do you know what is the meaning of hydrogen bonding? Hasan. Yeah. Intermolecular interactions. Have you done for all of us? Okay. So hydrogen bonding, have you done that? London forces, dipole? No. Okay. Yeah. So as a whole, we say that's why you can say here this is a hydrogen bonding because hydrogen bonding is a different definition. So these are called true interaction, real interaction within one single atom. Whatever these interactions are called true interaction, real interaction. Let's say we have this water bottle. Let's say අපි පැයක් එක shake කරනවා කියලා. Can you move these HOH bonds? No. Like if you do that, let's say that's a soda bottle or something. If you shake it and if you open it, so it gives the air away. So that is carbon dioxide. That is a different story, not breaking molecules. But here, regardless how much you are trying to break molecules, you can do that. You cannot get hydrogen separately away and oxygen separately away. That's never happened. That's why those are true bonds. But these bonds are time to time you can break. Such bonds are called van der Waals interaction or van der Waals bonds. Understood? Okay, the real bonds, true bonds, primary bonds are these covalent, metallic and ionic. Van der Waals are secondary interaction. Anytime it can break. අවුරුදු දෙකක් හොඳට ආදරෙන් ඉන්න අවුරුදු 5ක් 10ක් විතර එක පාට තරහ වෙලා මූණ බලන්න නැති වෙන්න පුළුවන්. So that's again temporary. But family අස්ස කට්ටියක් තරහ වෙලා definitely වෙන් වෙලා යන අයත් ඉන්නවා. That's like a real chemical reaction. Understood? That not happen frequently. Chemical reactions are special conditions. Okay, so that we have 4 different kinds of interactions here. ඒකේ මම van der Waals part එක අරගත්තොත් මට මෙන්න මේ van der Waals, this is van der Waals interaction. මම මේක කියලා දෙලා ඉස්සෙල්ලා. Okay, so I have taken here the I2 molecule, one of the I2 molecule. This is one I2 molecule. Zoom eකට tired වෙලා. We're going to go back and get out of the Zoom and then come back. When I'm writing, if it doesn't give, it simply means Zoom is tired. Zoom එකේ මගේ පොඩි research එකකින් හොයාගත්ත part එක. So one I2, then the other I2. This is one I2 molecule and the other I2 molecules. And then the closest atom of this red I2. This is red I2, closest atom of that. And then this is the blue I2, closest atom of that. Out of these closest atoms, if we choose their nucleus, and if we get the distance, if we divide that distance by 2, that is the van der Waals radius. Closest atoms get the closest atoms, and then get the distance between those two nuclei, and get the different distance, the half of that, that is the van der Waals radius. Clear that? Okay, so that one molecule and another molecule. There is a system not like that, but also one atom existing as a one single independent system. They don't react with anything else. In between those, again, those are independent systems, whatever monoatomic or polyatomic. One atom or more atoms are possible. Give me example for one single atom, one family. They live separately. They don't want to make any connection with anybody. Yes. Noble gases. Let's say, well done. So let's say this is argon. One argon, another argon. So that's again two different families. They don't want to get married. They want to make kids in their family, in their house. They live all by themselves. Understood? Okay, because they are happy. Why they are happy? Because they already feel like they are completed. Why? They have inner configuration, fully completed configuration, S2P6. Understood? That's why they don't want to connect it. Then get the difference between that. That D divided by 2 is again the same van der Waals. Understood? Okay, this is the full part of radius story. So that's why the very first Pedic property is little longer. So the very first Pedic property is there are 8. When you done these 8, we are done unit 1. The very first one is the size of atoms and ions. Ions, we're going to talk about these anions and cations. Make a mangwadi kivedani. Okay, so here you have atomic number and atomic radius. Okay, lithium and sodium. So if you go here, lithium is here and sodium is here. Now tell me why there is difference here. I mean the sodium is higher. Why? The radius of sodium is high. Why? Electrons are entering into new energy level. And see, same period, lithium to fluorine, it's getting down. Same period, sodium to chlorine, it's getting down. Why? Yeah, protons are increasing, so the attractions are high. These two diagrams are, have you guys seen these two diagrams? Yeah, it's from resource book. This is from resource book. So, resource books හදන්න university lecturers ටික ඒ කාලේ මාර try එකක් දුන්නා. සමහරක් කියවා proof reading මමත් කරලා තියෙනවා. ඒ කාලේ yeah මම ගොඩක් ඉතින් මගේ අර මම දන්න සමහරක් කට්ටියගේ proof reading මම බලලා තියෙනවා. ඔය industrial එතකොට equilibrium 12ම ටිකක් සැරයි නේ වගේ. So they did a very big, like hard, difficult job making these resource books. So they want you to read them. So to make sure that you guys have read them, what do? They make questions from resource books. Make sure you have the memory of everything of the resource book. And that's simple, that's easy. Alright, so that we done that part. Okay, so that may have the spaces still තියෙනවද? තියෙද? මේ හතර දාගන්න. ඉන්න. මෙතන අපි කියවේ නැහැ මේ ටික. මේ ටික කියවේ නැහැ. Let's read it. According to modern atomic structure, atom is made up of compact nucleus which is surrounded by diffused electron cloud. Due to the diffused nature, sharp boundary cannot be defined for electron cloud. Therefore, atomic radius is an imaginary concept. Instead of atomic radius, following terms can be used. What are those? Covalent, metallic, van der Waals, ionic. Okay, try this part. Okay, let's read. Covalent radius or covalent atomic radius. Half of the internuclear distance between two nuclei of a single covalent bond formed between two identical atoms. So the covalent radius equals this d divided by 2. Then make it 20 exactly same. Understood? Along a period, downwards group still the same. So downwards group radius increases. So covalent radius increases. Van der Waals radius increases. It's same. Ionic radius increases. So along a period, radius decreases. So covalent radius decreases. Ionic radius decreases whatsoever. Okay, so the covalent radius increases down a group. The covalent radius decreases from left to right across a period. Clear? Okay, so it's okay, really okay. If you want, you can use these different devices. But I want you guys to improve your own hand-eye coordination when you are drawing this. Okay, Amit, complete karega.
sister.
Open මම කියන්නේ මේ shape එක නෙවෙයි කියන්නේ right shape නෙවෙයි මේ දෙන්නා චුට්ටක් දැන් චුට්ටක් කරනවා දැන් මම මහන්නේ තව චුට්ටක් උඩ මහන්න මෙතන කියන්නේ පෙන්නේ තව චුට්ටක් ලොකුට අර පොඩ්ඩක් අයිඩියා එකක් එන්නදී මම ඉර දැම්මේ ඒක අයිඩියට නියුක්ලියස් එක දැම්මම හොඳට ලොකුට දෙන්න ඊට මැදට ගන්න එතන නියුක්ලියස් එකත් පෙන්නුණා ඒක ඒ කියන්නේ ඔයාලා if you guys draw such diagram for the final exam, that's fine. දැන් ඉඳලා ඔක අන්නොත් එහෙම final exam යද්දී මොනවා වෙයිද? ඔයගලගේ අකුරු තව තව කැට වෙනවා ඉස්සරහට. දැන් මේ හුරතල් කරන්නේ කිසි කෙනෙක් පස්සේ දැන් ඔයාලා යන හැම ක්ලාස් එකකම ඔයගලන්ට අර ටියුෂන් ක්ලාස් එකක් හොඳයිද නරකයිද කියන ඉන්ඩිකේටර්ස් තියෙනවනේ. ඔයගලන්ට too much spend කර එකම දේ 500 සැරයක් කී එහෙම යනවනම් ඒ ගුරුවරයා හොඳටම දන්නවා ඒ කියන්නේ මෙහෙම ගිහිලා හරියන්නේ නැහැ මේ ළමයින්ට එන්නට මේකලම හුරතල් කරලා පන්තියේ තියා ඉන්නවනේ වගේ එකක්. ඒතර ඒගොල්ලෝ මොකද කරන්නේ අන්තිම ටිකේදී රෙකෝඩින් දාලා ඔයගලන්ට මාර හાર્ඩ් ලයිෆ් එකක් දෙනවා. සිලබස් කවර් කරන්නේ අන්තිම මොහොත වෙනකන් ඉඳලානේ. ඉතින් ඒවා චෙක් වෙවි යන්න. ඔයගොල්ලන් යන ක්ලාස් එකේ සීනියර් කට්ටියට කොහොමද සිලබස් කවර් වුනේ කියලා රෙකෝඩින්ග්ස් දාලා කවර් කරාද normal විදියට කියලා කවර් කළාද කියලා. Okay. I'm moving. Okay. මේකත් කියවන්න. Metallic radius. Half the distance between two adjacent cation nuclei in the metallic lattice is the metallic radius. චුට්ටක් අහගන්න. So the metals, you don't want this one. We're going to do this one for the second unit, but anyway, just listen. So the metals, let's say sodium, so they have 3s1. Last shell electron is very, very loosely bounded away from the nucleus. And once you remove that electron, they can gain the inert configuration. So what happened is, let's say you have all those sodium atoms here. So they release this last shell electron out from the atom. But they just keep it like close by because negative positive attraction is still there. And then this is called the electron C. In this electron C, atoms are laying inside. Understood? This is called the metallic lattice. That is the metallic lattice. That's why they conduct electricity very, very easily. ඕක අස්සේ තිබිලා nuclear attraction කඩලා getting the electron out then moving to one single direction to make the current it takes time but without time like without thinking of us like with our speed without no time whatever the like when we switch on any switch it gives us the current is flowing. Why is that? Because already the electron is there, free electrons are there. Understood? So we're going to come to that part later when we are doing this second unit, but that is the meaning of metallic lattice. So the two nuclei get the distance divided by 2, that is the metallic radius. Make sure you're going to do this good job when you are drawing this. Scientific diagrams are not like arts, but scientific diagrams are supposed to have their like own neatness. Hesandu, someday try to get this compass away and do this all by yourself. Otherwise, you are not improving your own hand-eye coordination. ඔයකලා ડોක්ටර් කෙනෙක් වුණොත් ඔය අතට හම්බෙන්නේ නැහැ සර්ජරිස් කරන්න. Metallic radius equals d divided by 2. Okay, with these beautiful colors, this is from your biggest metals. Oops. OMG, just a second. And in the resource book, like they were done this good job, they were using these beautiful colors. You guys know that metals are having more atoms. So on this diagram, they were showing 4 different atoms. They are showing, so any of these 2 atoms, you can get whatever this distance is same. So either here or here, they were showing here and here. Sorry. Here is the total distance and this is the half of that metallic. This is metallic diameter and this is metallic radius. Okay. You guys have this best idea about what are these van der Waals interaction. We're going to do definitely all those interactions for the second unit because second unit is bonding. Let's read this. Van der Waals radius. 2 non-bonded isolated atoms of the same element can exist in a minimum distance without forming a chemical bond at solid state. Because this connection is not real chemical bond. Forming a chemical bond at solid state. The minimum distance that they can occupy is called Van der Waals distance. 2 different families can get closer to a certain level, not to like very close by. That distance is the Van der Waals distance. Therefore, Van der Waals radius is half of the intermolecular distance when the 2 atoms are at solid state without forming a chemical bond. Why they say it's a solid state? Because gases and liquids are continuously randomly moving. Solids are only stay still. Okay, so let's copy this part. Again, same. Van der Waals radius is d divided by 2. Okay. Finish. Okay, copy this. I give you the sharpener. I had one. Sharpener. Okay, copy this.
Water molecules value moon atoms
When they are in solid state, the closest. Hydrogen or oxygen, whatever the closest to.
Oxygen hydrogen
Yeah, even oxygen hydrogen is possible, oxygen is possible. So that's the van der Waals radius. It's not depending on the type of atom because it's the distance between two different atoms. And Baba, whenever they are making these bonds, and that bonds definitely have a proper orientation. Okay, now, he was asking if it is water, what would be these two? Then make it gathot then definitely these two atoms are iodine atoms. How will you know which atom of oxygen and which atom of water, oxygen or hydrogen? The thing is when you are making bonds between water, that connection always go between oxygen of one molecule and then hydrogen of the other molecule. Why is that? That is called the, okay, this is the van der Waals interaction. This is called the hydrogen bonding. Electropositive, electronegative. Negative, positive comes together always. Understood? Polarity, yeah. Because this is always getting delta minus and this is delta plus. Then always the van der Waals distance goes from here to here, then divide by 2. Understood? Good, fine. Okay, you guys done up to here? Okay, so let's read this part. Van der Waals radius can be defined for molecules. Van der Waals radius is then half of the internuclear distance between two adjacent atoms in each molecule when they are at solid state without forming a chemical bond. Clear? Okay. Fill that part. Then I will show you guys this diagram because my one is not clear. Then let's complete that one. Now tell me which radius is the greatest out of these three. Out of these four, there are like, let's say, metallic, ionic, and van der Waals. Which radius is the smallest, and which radius is the greatest? Hmm? What is the greatest one? Hmm? Largest radius. Van der Waals. Because those are not true bonds. Two families are away from each other. And the closest one is? No. Covalent. Why is that? Metallic dash, only metallic is like they are staying separately. Ionic, they are always away, negative positive attraction. But covalent, they supposed to get closer for the sharing. Let's say, just kidding. මගේ මේ nails ටික හිතන්නකො මෙහෙම අස්සේ යනවායි කියලා. So then the atoms supposed to get so much closer. This is the overlap part. Understood? So these two are the nucleus. So they have to get more closer. So the closest one is covalent. Right. Okay. Make a medical dagani. Me particle fill කරාද? Van der Waals radius can be defined for molecules. Huh? Done. Okay. අපි මේ ටික දාගන්න. බලන්න පොඩකින් බලන්න. මේක. This is covalent distance. And this is a half of that. 206 divided by 2 is 133. And this is Van der Waals. And this is half of that. 430 divided by 2 is 215. Okay.
What is PM?
What is PM? You guys know, and you guys know that, huh? No. You guys know this. We did calculations, not using this, but using nanometers. What is this one? PM, picometer. 10 power minus 12 meters. Okay, just write it somewhere. It's by. To both sides I have written. Have you done? You can part it up, a little part of that. Example is this I2 molecule, R equals D divided by 2. This is how the bonding pairs you can show. It's showing that 2 electrons are concentrating between 2 I2 molecules. Okay, copy this. Just a scratch is enough. Finish? Done. Hurry. Okay, we have another 15 minutes to be 10. 10 to 12 is the paper. Okay, so I want you guys to get the break now. I will post this to the group for online kids. So you guys can do the paper. ඊට කලින් මම paper පාඩු දුන්නද කියලා පොඩ්ඩක් check කරගන්න ඕනේ. මේක දුන්නද බලන්න? I guess I should. නෑ. Okay. For online kids, I'm going to post you guys the paper right now so you can get a photocopy and do it at home. Let's get the break until 10. Okay, at 10 let's start this. Alright, this paper has 25 MCQs that you cannot use any of these supportive knowledge when you are doing this 25 MCQs. That you're going to judge yourself. I'm not judging you. I'm not giving like වැඩ කරාද නැද්ද දක්ෂද නැද්ද. I don't check that. But you guys have to check yourself whether you guys are studying enough. Structured essays are really, really challenging. Then we're going to go through a brainstorming. Brainstorming mean you guys can discuss everything. So you guys, you put that මෙතෙන්ට ඇවිල්ලා මේ පැත්තට හැරෙන්න පුළුවන්. මේක table එකක පස්සේ when you are doing MCQs අර ඔයාලා groups හදාගෙන A group එක ASCII then you can check anything. You can check notes or everything. Just make sure that once you've done the 25 MCQs, just let's check that first. Then we can move on to the structured essay and essay. Okay, that's all for even for these online and students who will not get into the class physically. I'm going to end the meeting here. And so its time is exactly 10 now. Around නැත්නම් ඔක තිබුණා meeting එක 11 වලට එන්න ඕගොල්ලන් මේ marks check කරගන්න MCQ marks ටික. So you have 1 hour for MCQs. I want you guys to get a printed copy and do this. Time starts now. Right, it's 1 hour. When you are doing a paper, the very first thing is you have to go through this given questionnaire. You have to think like questions are longer, shorter, what is the time period and everything. Then you have to make your own plan. How would you do the paper? Like you have 1 full hour. For the final exam, let's say you have 2 hours. Then how long you are taking to do complete your first round? Usually I ask you guys to do around 70 minutes. Then here it's supposed to be let's like 40 minutes. And then another 10 minutes to check the second version or the longer, difficult, harder, maybe you don't remember the theory, such questions. Another 10 minutes, then 50 minutes, then you have another 10 minutes to recheck again and then write everything on your cortical answering sheet. We don't use that so far, but I'm going to give you guys later. Anyway, so let's move on to get answers. Question number 1, answer 1. 2, answer 2. 3, answer 1. Question number 1, answer 1. 2, 2, answer 2. 3, answer 1. 4, answer 1. 5, answer 1. 6 answer 2, 7 answer 4, 8 answer 2, 9 answer 1, 8 answer 2, 9 answer 1, 10 answer 1, 11 answer 3, 12 answer 3, 13 answer 2, 14 answer 1, 15 answer 4, 16 answer 5, 17 answer 1, 18 answer 5, 19 answer 3, 20 answer 1, 21 answer 3, 22 answer, there are two answers, 22 answer 2 or 4, 2 or 4, 23 answer 5, 24 answer 4, 25 answer 1. Okay. How many? Sajiva? Huh? Hasn't it?
16.
16. Isn't it? For this paper, highest was 20. Yes, damn. Do you guys want me to post the marking to the group? Huh? Okay. Huh? Q15. Okay, anyway, the second paper is very, very difficult. So what I want you guys to do is yeah, you guys can turn around and discuss and get answers. Then I would post some full marking after the class. Okay, I'm end the meeting here. Bye. Take care, everyone.